Hey everyone. So we're completely surrounded by batteries, right? They're on our phones, our cars, pretty much everywhere. But have you ever stopped to think about the invisible world of quality control that keeps them from, well, failing? Today, we're going to pull back that curtain and meet the unseen guardians that protect every single battery. Okay, let's dive in. It's a question that probably sits in the back of all of our minds. You hear these stories about devices overheating or worse, and we probably think it's because of some big, obvious mistake during manufacturing. But what if the real culprit is something else entirely? That's right, the real danger. It often lies at the microscopic level. A tiny, completely invisible flaw in an electrode can kick off a chain reaction that has very, very visible consequences. So let's go on a bit of a hunt and see how manufacturers find and fight these hidden threats. Okay, so let's get into why close enough is just not good enough. When it comes to making batteries, perfection isn't just a goal, it's an absolute necessity. The stakes are incredibly high, and it all starts with something called the electrode coating. This is where it gets really interesting because you can see how one tiny problem just snowballs. See, if the coating on an electrode is even slightly uneven, it messes up how the current flows. That creates these tiny hotspots, which leads to localized heating. And that heat makes the battery wear out way faster. That's what we call premature degradation. Worst case scenario, it can cause an internal short circuit. And that's the big one, the kind of failure we all want to avoid. So how do you even begin to fight these invisible flaws? Well, manufacturers have what I like to call guardians, these high-tech quality control systems. Let's meet our very first one, the weight test. Its whole job is to make sure everything is uniform right from the get-go. The official name for this is basis weight gauging. Now, the core idea is actually pretty simple, but it's brilliant. You check the electrode's weight and consistency using a really small, harmless amount of beta radiation. It's almost like having this microscopic scale that can weigh every single spot on the electrode sheet as it goes by. So how does this actually work? Well, first, you've got a source that's emitting a steady stream of these beta rays. As the electrode sheet zips past, it naturally absorbs some of that radiation. Then, on the other side, a detector is just constantly measuring how much of that radiation actually made it all the way through. So here's the key. If a spot on the coating is too thick or too heavy, it's going to block more of those rays. And boom, the system instantly flags that spot as a potential problem. And this is where our first guardian really shines. It's a master at catching those little inconsistencies. Streaks from the coating machine, little clumps of material, or even spots that just didn't get enough coating. All things that could lead to those dangerous hotspots we were just talking about. Okay, but what about the flaws that are already sealed up inside the battery? For that, we need to meet our second guardian, the one with, you guessed it, X-ray vision. Now this is a really important distinction. The weight test was all about the surface coating. This guardian, it uses similar technology, radiography, but for a totally different mission, to peer deep inside the finished battery cell without ever having to crack it open. It's looking for dangers that are completely hidden from view. So let's just break this down to make it super clear. On one hand, you have the weight test. As we said, that's all about checking for surface consistency with B-rays. On the other hand, that same core technology, often using more powerful X-rays, gets repurposed to create a kind of internal blueprint of the battery. It's hunting for a completely different set of bad guys, things like tiny metal burrs and cracks. And here's exactly what it's looking for. A tiny foreign particle, maybe a sharp metal burr that was left over from the cutting process, or a microscopic crack. Any of these could actually puncture the separator that sits between the positive and negative electrodes, causing a direct short. It also checks to make sure everything is perfectly aligned inside. No weird overhanging bits that could cause serious trouble down the line. All right, we have one more guardian to meet. This one is all about incredible speed, laser-like precision, and getting a perfect view of the surface. Let's meet the eagle eye. Just try to picture this, a whole bank of super high-resolution cameras watching the electrode sheet as it just flies by on the production line. That is the eagle eye. These automated vision systems are scanning every single square millimeter in real time to catch any surface defect that might have slipped through. And its hit list is, well, it's long. It's looking for the tiniest pinholes, clumps of material they call agglomerates, nearly invisible scratches, or even little bubbles in the coating. It can spot a single speck of dust, a tab that was cut just slightly wrong, or a coating that's just a tiny bit off center. The level of precision is it's absolutely astounding. So we've met our three guardians. But here's the thing. They don't work alone. They work together, and when they do, they form this incredibly powerful, unseen shield. You can think of it as a system of layered defense. The weight test makes sure the foundation, the coating, is perfectly uniform. Then, the eagle eye scans that surface for any and all imperfections. And finally, X-ray vision inspects the final internal assembly. Each guardian is essentially covering the other's backs, creating this comprehensive shield that stops failures before they can even start. And this, right here, is really the main takeaway. Quality control isn't just something that happens at the end of the production line. No way. It's woven into every single step of the process. It's this constant, vigilant process that makes our modern world possible. And, maybe more importantly, keeps it safe. So that kind of leaves you with a final thought, doesn't it? As we rely more and more on battery technology for literally everything, from green energy to exploring space, that demand for perfection is only going to grow. These unseen guardians, they're getting better and more advanced every single day. But the question still remains. As our ambitions get bigger, will our ability to make the perfect battery be able to keep pace?